So day 2, like I said, it is short trigonometry review, and then we're going to go into the geometry portion, which, includes some trigonometry as well. So trigonometry review, find the value of x, round to the nearest tenth, and I see that they want a side length. So the first thing I think of is something we talked about yesterday, the Pythagorean theorem. But I realize I don't have enough information to use the Pythagorean theorem because I need 2 sides, and I only have 1. Then I noticed they gave me this new piece of information. Whoops. There we go. 33 degrees. And I remember I can use trig to find ratios of the side lengths. So if this is my 33 degrees, this side is opposite, and this is hypotenuse. And I remember SOHCAHTOA. And I look for one that uses opposite and hypotenuse, and that's going to be sine. So the sine of 33 degrees equals x over 14. So to solve this, I have to get x by itself, which means I'm going to multiply both sides by 14. Because remember, the sine of 33 degrees, that's in my calculator. It's a number, it's stored in there. So if I punch in 14 sine 33 degrees, I'm going to get x. But again, remember yesterday when we cleared the memories, we had to make sure our calculators were in degree mode. Some of you that borrowed one from me today, you're going to want to take an extra second here and go under mode and make sure that you're on degrees. Otherwise, you're going to see some pretty wacky answers. 14 sine 33. And it said to the nearest tenth, so we're going to go with 7.6. All right, let's look at number 2. There's the angle that they've given me. Now we use those labels of opposite, adjacent, and hypotenuse to figure out what we have. So what label should we give the x? Adjacent. What label do we need to put on the 14? Think SOHCAHTOA. Which one of the trig functions uses adjacent and hypotenuse? Cosine. So cosine of 37 degrees equals x over 14. How can I get x alone? Multiply both sides by 14. And again, that cosine of 37 is stored in our calculator. So if we just punch in 14 cosine 37 degrees, 11.2. Number 3, here's our angle. What should we label that side that says 6? Opposite. How about the x? Think SOHCAHTOA. Which one should we use? Tangent this time. Tangent is opposite over adjacent. So tangent of 68 degrees equals 6 over x. And now we have a new problem. You can't have what you're trying to solve for in the denominator. So the first thing we would have to do is multiply both sides by x to get x out of the basement. But x isn't alone. So what are we going to do with the tangent of 68 degrees? Remember, this is just a number. What would we normally do to get x by itself? Yeah, divide. So we're going to have to divide both sides by the tangent of 68 degrees. So we need to punch in 6 divided by the tangent of 68 degrees. 2.4. So, using SOHCAHTOA to find missing information. That's not going to stop as we turn the page. We've got a couple of word problems. And one of the big things you should have learned in geometry was, if you don't know where to start, draw a picture. draw a picture, you can usually figure out what's going on. An escalator at a shopping center, so they look like that, is 20 feet 9 inches long. Almost wrote. Oh, it's 200. I was thinking it was 20. 200 feet 9 inches long. Now, I already don't like that because the labels don't match, but let's wait and see what they want the answer in. And it rises at an angle of 15 degrees. So that means from the ground to the top of the escalator, it's 15 degrees. Definitely not to scale. None of the pictures that we're going to see today are to scale. That is not 15 degrees, but I'm just going to label it that. What is the vertical rise of the escalator? Vertical means up and down. Round to the nearest inch. Well, that tells me I can't use this. I'm going to have to do some converting. So right now it's 200 feet. What do I do on my calculator to get that to be in inches? And then we have that extra 9 inches. So we have 2,409 inches. Now, let's figure out which of those trig functions we should use. If this is my angle, what should I label that x? Opposite. How about the 2,409? Hypotenuse. Think SOHCAHTOA. Which one? Sine. Sine of 15 degrees equals x over 2,409. How do we solve this one? All right, calculator. Put my glasses on here so I'll get that in there, right? 2,409 sine of 15. And it said round to the nearest inch, so we're going to go with 623 inches. So draw a picture. Geometry, it's so important to draw those pictures. 12-foot long ladder is leaning against a wall. Makes a 77-degree angle with the ground. Here's the ground. How high does the ladder reach on the wall? Round to the nearest inch. Oh, I already see an issue. What do we have to change first? 12 feet. So 12 feet is how many inches? 144. So I'm not going to use the 12 feet. X, what's the label? Opposite. 144, what label? Which trig function? Sine again. Sine of 77 degrees equals x over 144. So how do we solve it? Exactly. Multiply both sides by 144. Bless you. And then we grab our calculator and we punch it in. And this one was nearest inch as well. So about 140. And there it is. So pictures, big deal when you're talking about trig. Now this is backwards thinking. We were just using things that gave us the angle, and then we had information to figure out what the other side length was. This is saying, figure out what the angle is. So that's undoing what we were just doing. That means we have to use the inverse sine, inverse cosine, and inverse tangent buttons on our graphing calculator. Now, those are second functions. You'll see them in blue above sin, cos, and tan. So when we punch these in, we're going to have to hit second and then those buttons. But we need to know which button first, so we need to do some labeling. There's the angle. What does the 17 get for a label? Opposite. How about the 11? Think SOHCAHTOA? Which one is that? Tangent. So the tangent of x degrees equals 17 over 11, but we want the angle, so we're going to punch in inverse tangent of 17 over 11 equals x degrees. Should just keep my glasses on today. And nearest tenth, 57.1 degrees. All right, let's go after number 7. Here's our angle. What does the 12 get for a label? Opposite. 29. Adjacent. Well, that's the exact same trig function. Tangent of x degrees equals 12 over 29. And we'll do inverse tangent of 12/29 to get x degrees. 22.5 is the number of degrees. So now that we're done with that one, you would be able to complete the one that says homework 1 through 6. But we're going to go on. Initially, I thought, I'll just hand out the geometry review and I'll let you work on it. And then I went through some of the problems and I thought, you know what? It's been a couple years since I've taught geometry. If anything on here seems like, I might have to look something up because my mind needs to be refreshed, then probably for you guys, you need that refresher too. So, 2 things. There are formulas in the back of our textbook. They start on page 979. So if you've forgotten distance formula, even Pythagorean theorem, that kind of stuff, that's all on page 979. And then geometry formulas, surface area, volume, circumference, all that kind of stuff, page 985, if you've forgotten about those. Drew?
Don't we get a formula sheet on the ACT?
You get a formula sheet for both the ACT and the MCA. They have different things on them, I remember thinking the MCA, it's really weird. The MCAs give you y equals mx plus b. Who needs that one? We all know that one. They don't give you y minus y sub 1 equals m times the quantity x minus x sub 1, which most people need. So it's kind of a mixed bag. They'll get some of the formulas, but not all of them. All right. So geometry review. Grab that one. And right off the bat, I thought, number 1 is going to be tough for you because I know when I was teaching geometry, one of the hardest things for my students to do was draw in what are called auxiliary lines. Because you think you should be able to find everything from all the lines they gave you. Sometimes they make it so that you have to put more information on here in order to get it. So if arc AB is 80 degrees, so from here to here, 80 degrees, and BC is 60 degrees, right here, in a circle with center O, then find the degree measure of angle CAO. This little bugger right here is what we're trying to find. You can't do that with just the stuff that they have in this drawing. What you have to do is you have to draw in an auxiliary line from O to C. And what that does is it creates triangle AOC. Now let's see what everybody remembers. If from here to here is 140 degrees, how much is this angle right here, angle AOC? So we've totally forgotten about circles from second semester of geometry. All right, Whatever this arc measure is, this angle is exactly the same thing. So this was 140, this is 140. Now that's not the angle I need, but that's a big help because this is a radius and this is a radius. That means this. What kind of triangle is that? It is isosceles. And if you have two sides that are the same length in an isosceles triangle, what else is the same? The base angles. So if we take 180 degrees for every triangle and subtract 140 degrees, that gives us 40 degrees to split evenly between our two little angles. So how much are our two little angles? Yeah, they're each 20. Which again, you can't get unless you draw another radius on there and start looking at what you have. So that was a good one to do together. 2A and B, I know you can do because that's the 45, 45, 90, and 30, 60, 90 that we did yesterday. Now, I didn't do this one with second hour, and then I got asked like 5 questions about this one. So let's see if you guys can do a little bit better here on telling me what's missing, something that you know that you can put in. And the key here is that these little runners mean that those two lines that are horizontal, those are parallel to each other. So, can anybody help me out with an angle or a place to start? Carter? You want to come draw it? It's not. Yes. Anything else? Anybody? Drew, you got something you can put up there? They always put one of these on the ACTs or the MCAs, or both. 70 degrees. Good. All right. Because every straight line is how many degrees, everybody? Always 180. Now, if that's the case, we know this one is 110, but there's an easier way to know that it's 110. And that's because it's a bow tie angle. Bow tie angles get the special name in geometry of being vertical angles. And vertical angles are always congruent. So if this is 110, this little bugger over here is 110. If this is 70, this little bugger over here is 70 degrees. And because we have parallel lines, that means corresponding angles will be congruent to each other. I'm just going to scoot that over a little bit. So this will be 70, 110, 70, and 110. Notice how it's the exact same order, the exact same look up there? Now, how many degrees are in every triangle? 180. So far, we've got 105. So what's left for the other one? 75. I don't know if I can fit that in there. Let me do this. I'll put a 75 and a little arrow. So if that's 75, this vertical angle over here is 75. How about the other two? How much are they? 105. And then you just copy those numbers down here in those corresponding spots. So this is all of that learning about alternate interior angles that you did, alternate exterior angles, all that kind of stuff, all included in there. All right, 4, I thought we probably needed to just talk about whether or not anybody remembers the distance formula. Anybody remember the distance formula? Okay, and that one will definitely be given to you on the tests. So distance equals the square root of x sub 2 minus x sub 1, the quantity squared, plus the quantity y sub 2 minus y sub 1 squared. and you just use the points as x sub 1, y sub 1, x sub 2, y sub 2, and you plug them in. So this is where, like I said, in your book, page 979 has that one. So it'll be the square root of 4 minus a negative 2 squared plus 7 minus 3 squared. 4 minus negative 2 is what? 6. 7 minus 3? 7 minus 3 is, thank you. 6 squared? 36. 4 squared? Square root of what? $52. And then if you look down at the answers and they're multiple choice and they're all decimals, then you know to punch in square root of 52. So you can see what it is. So that's the distance formula. And that was another one that I had circled as, hey, people are going to have forgotten what the distance formula is. Number 5 is one of the reasons I gave you this blank sheet of graph paper. I think you're all capable of doing number 5 if you use the graph paper to do that one. 6 is perimeter and area. You can do that. 7 is find a diameter if you're given the area. I know you can do that. 8, I thought maybe we better look at. The hypotenuse of a right triangle is 182 feet. And the shorter side is 840 inches. Anybody see an issue already? Yes, different labels. Find the length of the longer side in yards, different label again, and find the area of the triangle. So 2 things to do. First, let's put them all in feet. I think that'll make it a little bit easier. So if this is 840 inches, what should I type in to get that into feet? Yep. So 70 feet. I'm not going to use that 840. I'm going to use 70 feet. Any ideas how we could get the other side? Yeah, let's use the Pythagorean theorem. We did that yesterday, so we'll make that one x. X squared plus 70 squared equals 182 squared. X squared plus 4,900 equals, I don't know, we'll have to punch that one in. Not many people have 182 squared memorized. 33,124. Then what do we do? All right. I'm going to put these on so make sure I'm doing this right. 28,224. Then what? Square root of toot toot. And hope for the best. Hope it's a perfect square. Good, somebody already got it. 168. But that's 168 feet. And they didn't want that answer in feet. They wanted it in yards. So what do we do with that? Yes, this one's a lot about just labels. 56 yards. And we're not done. Because it also said find the area of the triangle. So, formula for the area of a triangle. 1/2 base times height. And our base here is 70, and our height is 168. So let's see what that comes out to be in square feet here. So 1/2, 70, and 168. 5,880 square feet. 9, I think you're good for. 9 should be fine. Ooh, similar triangles in number 10. All right. How did I know it was similar triangles? Do you see it up there? This itty bitty little bugger right there means similar. Do you remember what similar means? Same shape, different size. Same shape, different size. So if it's the same shape, that means the angles are all the same. So it said they're both isosceles. If this is 118, how can we find each one of those? What should I punch in? 180 minus 118 gives me that. Yeah, base angles would be the same. So 31. So they're similar, which means the exact same angles are in the other triangle. But here's the difference. Their size is different. So what we do is we set it up either small to big, or big to small, big to small. 7 matches up with, I don't know, and 12 matches up with 18. Small to big, small to big. How do we solve something that looks like that? Cross multiply. So we need 7 times 18, 126, and divide both sides by 12. 10.5. Oh, no labels. Okay, well, 10.5 it is. 10.5 units, whatever it is. So proportions to work with those similar pieces, different sizes. Number 11. I don't know, maybe this is too easy and I shouldn't have put it on the list, but let's take a peek at it. Because it uses the word apex, and your geometry book doesn't use apex. Find all the angles in an isosceles triangle if each base angle is 4 times the size of the apex angle. This is the apex angle. It's the one in between the two isosceles sides there, the two sides of equal length. So, do we know the size of the apex angle? What do we know about the base angles?
4 times the size.
Well, then each one of these is 4x. How many degrees are in every triangle? 180. 4, 8, 9x equals 180, and I'll leave that one to you because I know you can get that one. And then plug it back in so you can find all of those angles. 11, I had a note to remind you that, or no, not 11, 12. Picture is definitely not to scale. Don't go by the picture. Go by the angles that you find, because you should find some 30, 60, 90 triangles in that one as you work through it. 13 is another circle one. Find the length of minor arc AB. Given that angle AOB is 40 degrees, and the radius of the circle is 5, with the center at O. And then it says, by the way, just so everybody remembers, a circle equation with a radius of 5 would be x squared plus y squared equals 25. But here's the issue. We have a formula for this that is fantastic. It is super short, and you saw it one day in geometry. That's all you saw it for. S equals r theta, where S stands for arc length. And here's the catch. The angle has to be in radians. Theta must be in radians. So that means you have to remember how to take 40 degrees and change it into radians. Anybody remember the conversion formula to change degrees to radians? I'm not surprised because you saw it one day. That was it. So we have to take it times pi over 180 degrees. That's how we get degrees into radians. Well, we could take a 10 out of both of those, and then we could take a 2 out, and that'll give us 2 pi over 9. So our little formula S equals r theta is going to be S equals 5 times 2 pi over 9. which will be 10 pi over 9. And if you look down on the ACT answers or MCA answers and you see decimals, then just punch that in, and see what it is. Everybody knows we have a pi key on the calculator, right? So if you wanted this one as a decimal, you could punch in 10 second caret symbol and then divide that by 9. It's about 3.5 as a decimal. All right. Oh, yeah, the circle one that's right below that one. That was another one. You can't get the answer with just what they have. Find the circumference of the circle given that BC is 12 feet. Well, circumference is 2 pi r. We don't have a radius. And you can't find the radius with just what they have up there. You can't do that. So what we have to do is draw in the central angle right there. What kind of triangle do you suppose that is? It is isosceles. It's got something else special going on. What's the other special thing? It's a 90-degree angle. Remember, you double the one that's all the way across the circle, you double it to get what it would be at the diameter. So that would make this a 45, 45, 90. Do you remember from yesterday? If we have the hypotenuse and we need a short side, what do we divide by? Square root of 2. And then we rationalize the denominator. And that will give us 6 square roots of 2. So 2 times pi times 6 square roots of 2, which will be 12 pi square roots of 2. And there it is. Again, it's one of the toughest things for geometry students to learn to do is draw auxiliary lines. Put in things that aren't already in the picture. It's okay to do that. 16, graph paper. That one you won't be able to do without the graph paper. 18. In order to solve 18, you have to remember the formula to find the sum of the angles inside a polygon. Because we have to find the sum of the angles for an octagon. Anybody remember the little formula to find that? This one you used for an entire chapter in geometry. It's been too long. Memories are drained. N minus 2 times 180. So you take the number of sides, which in this case is 8. Subtract 2. That gives you 6. And I'll leave it to you from there because I'm sure you can get it after that. All right. So the rest of the time that we're here today, I want you working on the one that says homework 1 through 6, and the packet we just were taking a few notes on for geometry review. So that's your assignment, is to finish those little buggers up for Monday. It is possible, I know your memories are not perfect with geometry because that was distance learning and COVID and all of that, but it would be possible to finish this before we get out of here if you remember your geometry stuff.